All right, we got recording rolling again. It's been later in the class. You guys have some time to look at these and think about these, but I definitely want to make sure that you guys are on the right track. Since it's not like multiple choice, I think that you guys can help each other out, ask me questions. But I want to cover let's look at these two, right? 61, 66. Make sure you guys are doing this right. Okay, kind of the volleyball, we looked at the mass of the volleyball, said what speed it's coming in, and then it's boing, about hit back the other direction with a different speed. Opposite direction is a very important detail because these are vector values, right? What average force did she apply? And they told you the time interval of collision. So here's a summary of, whoa, let me zoom out here. Here you go. Okay. Here's a summary of those details. This is what happened, right? So while it's coming to the right, then bam, it's hit right here, tiny time interval, and then it's hit back the other way. Okay. So did you guys set up an impulse, which is force? It's really average force, right? Times the time interval. That now I've been writing delta t for time interval. That's really what I should call this, right? Delta t. You guys know that delta t. Whenever I write delta t, you guys know that refers to a time interval, right? Okay. Okay. That's equal to the mass of the ball times its change in velocity. Hey guys, change in velocity is that final minus initial velocity, right? Final minus initial. Okay. Let's pop these numbers in. You guys are solving for f average. Solve for that. Okay. You can just pop this number in right here, 0.025 seconds. Okay. Then divide it over, right? Eventually, algebra step. The mass of the ball is right here. This many kilograms. Here's your volleyball. Okay. All right. Now here's the critical point that I hope you guys got this, but we're gonna find out. What did you guys get for the change in velocity of that ball? 6.2. Ah, yeah. See, we got it. Did everybody else get 6.2 meters per second? Okay. Because it ended up here, let's call the left let's call the left positive and the right negative. How about that? Right. So don't you actually have to slap a negative sign on this guy? Because different directions, right? So it ended up going 2.4 meters per second. So final minus initial, but the initial was the opposite direction. So it's like I'm subtracting a negative. This many meters per second. Is that true? Is that? Okay. And if you do 2.4 minus the negative 3.8, that is 6.2 meters per second. So it's like you're adding the speeds because there's a direction change. Right. And but I bet you guys can do the algebra and get it from there, right? You guys can do that? Is that right? Okay. Okay. Right. The other one I want to look at real fast, since you guys have some time, but you guys have all had a chance to look at number 66. We got a ball of given mass, so they told you how many kilograms, is going to the right, its own initial velocity. It's acted on by an impulse, but they gave you guys a graph, force versus time. Well, you guys see hanging from my ceiling, I have a poster that looks very similar to this. Okay. So is it true? Force versus time, the area under the curve represents the impulse. And a lot of times these are triangle type graphs. If you run this equation, remember this F we're solving for is actually F average, which makes like a rectangle shape. Okay. But if you actually have the actual data like plotted and have it like a triangle shape, it's just the area of the triangle is the impulse, isn't it? The change in momentum, right? So how would you finish this out, like write an equation? Well, I'm going to treat this as an open system. Open system. Okay. Now, if the system was closed, I could say that the sum of momentum initial equals the sum of momentum final. Right? That's like a closed system. But if it's open, like there's an external force acting, that means there could be a change in momentum called an impulse, right? Okay. So isn't the initial momentum mass times initial velocity? They gave you that, check. They gave you that, check. You just pop the numbers in. Okay. Now, the way I'm interpreting this is they gave you a positive velocity because they said the speed in the positive direction. This is positive velocity. And also the force is positive. So I think the ball is like moving to the right and you bump it further to the right. So it just speeds up to the right. So there's no like, the way I'm interpreting this is it's not a direction change like it was for the last question. The last question is a direction change. So ooh, careful with your signs. But this one, I think it's all just positive numbers. So can you guys do like the area under F versus T right here? That's not truly like proper math notation, but you guys get the idea. It's the area of the triangle, right? On an F versus T graph, okay, is the impulse. Okay, that's what that is. Okay. And then that'll give you mass times final velocity. And could you guys solve for the final velocity? Right, you guys do that? Okay. All right, so there's a couple hints, and yeah, All right, so I think you guys should definitely be able to get the rest of this, but if you have any questions, then definitely let me know.